there everyone. Today we are going to discuss this problem, assign cookies from Leetcode. So first of all, let's have a look at the problem statement. And now since this problem is very easy, so we will directly go through the problem statement first and then we will directly have a look at the code. There is no much logic to explain over here. You will understand it as we move further. So first of all, let us start with understanding the problem statement. So assume you are an awesome parent and want to give your children some cookies, but you should give each child at most one cookie. Each child I has a grid factor G of I, which is the minimum size of cookie that the child will be content with, and each cookie J has size S of J. If at any point of time S of J is greater than or equal to G of I, we can assign the cookie J to the child I and the child I will be content. Now what we have to do is your goal is to maximize the number of your content children and output the maximum number. Okay, so that was the question. Basically you will be given with one vector that is of name G, which is indicating the grid of the ith children that you have, and you will be given with one more vector that is S, which will be indicating the values of cookies that you can give to any of your child. And now you have to assign this cookie which are present in S to your children grids in G such that you are able to make child happy or content with your sharing. So how you will do it? So first of all, let's have a look at this example, that is example 1. So in example 1, we are given with the grid as 1, 2 and 3, and the availability to us is 1 and 1. So basically the cookie size available to us first of all is 1. So you can contain the child which is having the grid with 1. Okay, so you can give this cookie of size 1 to this ith, that is 0th index child, and you will be able to make him content, but you won't be able to make this child number at index 1 and 2 content as you don't have anything, as you don't have any cookie of size greater than or equal to 2. Correct? So that's why the answer over here is 1. Let's again have a look at another example, that is example 2. So again over here you have a child with grid is equal to 1, and yes, you also have one cookie of size 1, so you can make him happy. Again, for another child the grid is equal to 2 and you again have a cookie of size 2 with you, so you can also make this child content. So over here in this example you are able to make two child totally content, so that's why your answer over here is 2. So now if you go for the logic is very simple. We will try to assign the minimum size of cookie to the minimum grid person. Okay, so in this manner we will be able to save up the cookies of large size so that we can use that later on to satisfy the higher amount of grid. Correct? So this is it. This is the simple logic that should come to your mind, that minimum size of cookies should be assigned to the minimum grid person possible, and the maximum size cookie should be assigned to the person having maximum grid. So if you share in such a manner, then you will be able to make maximum child content with your sharing methodology. So that was the logic. Now directly let's have a look at the code. So to do this, first of all, I have sorted both of this vector in the ascending order, that is G and S. And after that, I made two pointers, that is pointer 1 and pointer 2. Pointer 1 is for the vector G and pointer 2 is for vector S. And I will be going size of the respective vectors. So while at each and every point of time, I will check if the S of pointer 2, basically consider this as G and this is S as given in this example 1. So initially my both the pointer, that is pointer 1 of this vector G will be at index 0, and pointer 2 of this vector S will also be at over here, that is index 0. Now what will happen? We will check that if S of pt2 means if the value which you are currently at, is this able to satisfy the grid of this ith person or not. First of all, before doing this, we are sorting it in ascending order. Okay, so keep this thing in mind. Once you have sorted, then and then you can apply this logic. We have kept our two pointers initially at index 0, and we are checking that if we are able to content, initially we are over here, if wherever we are in our s vector using that value, if we are able to content that ith person in the G vector, then we will do it if it is possible, and we will move both the pointers ahead, because since this person is content, so this is no longer into our consideration. So we'll increase our pointer 1, which is indicating any element in G vector by 1, and we will be also incrementing our pointer 2 by 1. But if this is not the case, let's say over here when the pointer will be at this index number 1, and the pointer 2 of this s will be also at index number 1, so over here this condition won't be satisfied. It means that s of pointer 2 will be lesser than g of pointer 1. This condition is not satisfied. It means that whatever size you are currently have, you won't be able to satisfy the greed of the person using the size of the cookie that you currently have. So what you can do over here is, you can keep this pointer, that is the pointer 1 of vector g, over the same position, and we will try to increment the pointer 2 of s in order to find any number which can be later on will be able to satisfy this greed of higher number, right? So it may be possible that after 111 there will be some number, let's say 3, so in that case it will be able to satisfy this greed of 2. So that's why whenever this condition is not satisfied, we will only incrementing the pointer 2, which is pointer for vector s. And at the end of the day, we'll be returning our answer. And yeah, whenever this condition is satisfied, whenever we are able to content any person using the size of cookie that we have, at that time we will increment our answer also, and at the end of the day, we'll be returning that answer. So that was it. That was the simple solution. Let's try to submit it and have a look. Okay, so yes, it is accepted. So yeah, that was it. That was the simple solution. And if you have understood it, please give a big thumbs up to this video and subscribe to our channel for more such content.